Okay, so here we have you have cards with numbers 1 to 5 on them, right? There's a limited supply. I told you that already, but you literally, it's saying no repeats. Ouch, and no repeats. Okay, it's another way of saying no repeats, basically, right? You understand that? Because you're taking and there you have fewer left for the next slot. So just be careful. Sometimes I use different wording to do the same thing. How many three-digit code numbers can be made using these cards? So yeah, I know this. I hope you tried it. So we have 5, 4, 3. No problems there. I hope at least. This one should make sense. I'm just going to have my key up here. So this is 20 times 3 is 60 numbers, right? Sometimes it's code, sometimes it's numbers. Same thing. How about this one? How many different even three-digit numbers can you make using these cards? So there's a restriction, right? Restriction. Or condition. But there is an overarching condition already. What is it? Way at the beginning. This is also a restriction, guys. You're gonna hear me? Restriction, right? So right off the bat, you're given a restriction, the original problem, and then I add a layer, another layer to it. So you have to be careful there. Okay, so 3 digits still. It has to be even. Okay, so I would take care of that first. So that means that an even number has to end with an even value. Okay, so your choices would be 2 or 4. And in this case, you can just leave it like that. So you've got 2 choices. I will circle this. Right. First, do this first. Right, and then I take care of the rest. So you're saying there are 2 options to make this happen. Okay, and then how many cards are left if you take 1? You almost have to consider this as 1 has been taken out of the stack, and you're like, but what about the 2, Mr. Dirksen? I think I will do cases after this for you to see what's happening. But there are 4 left, and then 3 to do the next slot. So 4 times 3 times 2, that is 4 times 3 is 12, times 2 is 24. And let me do cases. That's why I like to do cases. Because really what this was saying is that the number can end with a 2 or it can end with a 4. Understand that? So what really happens is ends in 2 is your first case. So let's do that. 1, 2, 3. Let's say it ends with a 2. There's only one option for that, right? You follow that? And so that means that you have 4 times 3 left. So how many would that be? 4 times 3 times 1 is 12, right? If it ends in a 4, which is my other option, you repeat this. So if it ends with a 4, then it's 1, and you've taken 1 card out, so it's 4 times 3, that's 12. If you add the cases, you get how much? 24. Okay, so it matches. So when you do a case where there's or, right, you put down the number of options, but you almost, to fill in the rest, you almost consider that only 1 card has been taken. Okay, 1 card has been taken by doing this, by fulfilling this restriction, and now you're left to 4 cards and 3 cards to do the remaining. Or you can split this into cases, right? And you will see that the 2 is kind of taking care of that happening twice. Shake that off, right? You're talking too much, Mr. Dirksen, my head is spinning, right? C. How many 3-digit numbers are greater than 300? Put restriction there. Right there. Are greater than 300, so that's one restriction. And is there anything else in this case? It's just greater than 300, but there's already another restriction way up there, which is no repeats, right? Remember? So there are really two restrictions. 1, 2, 3. Greater than 300, I need to take care of that first. Which one would that affect? Which slot? The first number, right? So greater than 300 means that, hold on, I think I need to fix the wording. No, it's good, we're good. This could be a 3, a 4, or a 5, correct? And the rest doesn't matter because there is no 0 in this case, right? 0 is not an option, so I cannot get a 300. So all of my numbers will be greater than 300, correct? Because 1 is the lowest. So this could be a 1 back here. So I don't need to worry about the 300 or greater or whatever. So I will put down 3 here. You've got 3 options. I took care of that restriction. Okay? Took care of that restriction. And then how many cards are left? If you fulfill this restriction, you go this, or this, or this, right? So how many cards are left? 4 times 3, okay? 4, 3. And then, so this is 9 times 4 is 36. Numbers. You can do this into cases. You want to do cases? You're like, no, I don't want to write more. My hand hurts already. But you could do 3, 4, 5, right? There'd be a 1, a 1, a 1. You fill that in, you get 36, okay? You're feeling the pain already? Okay, let's step it up a notch. How many different 3-digit even numbers? Here's that thing again, the restriction. Write it down. Circle it, write it down. Even numbers are greater than 300. So you're narrowing it down, right? You should get less numbers now. Okay? So this is restriction. So can we do restriction number 1 and restriction number 2? And then we make our 3-digit codes. Dun, dun, dun. And here's going to get interesting. This is where you need to do cases. So let's break this down. Even number would tell me that at the end I would have to have, based on my options, a 2 or a 4, correct? And what is the other restriction? That the front needs to be 3, 4, or 5, because I need to have greater than 300. Do you see a problem there? What's the problem? It's a Venn diagram problem. Are they mutually exclusive, these ones? 4 and 4. So you're like, wait a minute, there's some overlap. If I do it as it is, I'm going to double count. Can't do that. Okay. So I didn't leave enough room here. So you're just going to have to go with my. So what I will do is I will split this into case 1, right? Where I will make this number end with a 2. I'm just going to worry about all the numbers that end with a 2. And then case 2, what is that going to end with? With a 4. What am I going to do with these numbers once I get them? I'm going to add them. Okay. So if it ends with a 2, this is not affected, correct? So I only have one option back here. I have how many options? 3. Think about it. This did not affect that. So I actually have 3 options. And how many cards are left for that last slot? One card gone, another card gone, so you're left with 3. I know this is painful, guys, but you're going to have to do this on your own. I'm going to give you enough examples to try this. And getting it wrong is part of learning. Do you know that? Getting it wrong is part of learning. So don't be like, oh, there we go again. I got it wrong again. As you start doing these, you're going to be like, yep, I know what to do. I see this pattern. Mr. Dirksen talked about this. I got it wrong before, but now I know because I'm looking for words, right? So this is 9. Okay. Or case 2 is where it ends in a 4. It still needs to be greater than 300. So I'm left with 3 or 5, right? So here I had 3, 4, 5 because that even number did not affect. Now considering it ending with a 4, I only have 3 and 5. So I have one option and you have 2 options. So one card gone, another card gone. How many are left? Hi there. Thank you very much. That's awesome. Anyways, 2 times 3 times 1 is 6. So I know I should have left you more room. I know. 9 plus 6 is 15 numbers. And there is ways of double checking because you should get a number that's less than 36, right? Because all numbers greater than 300 is here. And if there's another restriction put on that, you're shrinking it. Okay. Here we go, another one. Let's make this really big here. Cases, okay? Like make it stand out when you come down to this page. And we will do more, so don't worry about this. Is not going to be the only cases example, okay? How many 4-digit numbers greater than 3,000, right, can be made if it has 2, sorry, this is a typo, has 2 end and a 4 or a 2. So we're going to go 1, 2, 3, 4. Set it up first of all. This is a restriction. And this is a restriction, right? It has to end. And what I would suggest you do is you're like, okay, 2 or 4, okay? Because it's a 4-digit number. Yeah, I feel it. Yeah, you gotta watch, you gotta always question my questions because I could make a mistake. So this means that in the front it would have to be a 3, a 4, or a 5. You see the problem? You see the Venn diagram overlap, right? Can I do this? I hope this isn't gonna. It's overlap. Overlap cases. Okay. You need to split it into cases. Okay. So what am I gonna do? I'm gonna go like this. Case 1. And you have the video, okay? So maybe at the top of this page, write down October 7th. And if you ever go through these notes, you're like, what did he do there again, right? You go back to October 7th and look up the video. So anyways, if it's case 1, it ends with a 2. I have one option here. The 2 doesn't affect the front runners here, so I still have 3 options. So I took one card, I took another card, so I'm left with 3 and 2 to fill in the rest. So 3 times 3 is 9 times 2 is 18. Case 2 is 1, 2, 3, 4. In this case, I'm going to consider that 4, but at the front, I only have 3 or 5 because the 4 is gone. And the reason this is a problem is because at the very beginning, you could not repeat. That's why you're doing this. Okay. If repeats were acceptable, this would not be an issue. Okay. So you have obviously just one option, 2 options, right? and you took one card, you took another card, so you're left with 3 times 2. And that's 2 times 2 is 4, times 3 is 12. Okay, so 30, no, not 30. 30, yeah, 30 options, 30 numbers. Possible. And I could do odd, I could do, you name it. Okay. All right. I'm going to keep going a little bit more, guys, because how many ways can letters of the word pre-cal be arranged? This means, right, limited supply, which is another word for no repeats. Like they're basically saying, hey, all you have is these letters. That's all you have. And this, like, let's say we cut it up, we put it in a bag, right? So you've limited supply. So how many slots am I supposed to fill? 1, 2, 3, 4, 5, 6. 6 letters, right? And so basically what you do is there's 6 for the first, 5, 4, 3. This is a classic in math, guys, in probability, stuff like that. Arrange letters in a word, and that's how you do it. We notice that there are no repeats here in the sense of like applied has 2 P's, right? I couldn't use applied just yet. That's coming, okay? We're going to have to address that. So this is 720 ways. I think I'm going to have to park it there because your brains are thinking of the weekend already. Let me just see if I can. Was there a textbook assigned? Let me just go back here. Yeah. If you haven't done this, then I strongly encourage you to do these in the textbook, okay? Grab as many as you can and just start working through them. Get familiarize yourself with license plates and all of that, and passwords. What if a password, this is coming your way, what if a password could contain special characters? Right? Remember, it's only letters or numbers 0 to 9. What if I added, exclamation mark, question mark, number sign, hashtag, whatever? Like what happens, right? There's more options, obviously, but start getting your brain into that mode, okay? Thank you, guys.